Hello. Today we are going to be taking a look at lesson 1-6 called Solving Compound and Absolute Value Inequalities. If at any time you need to pause this or rewind it, feel free. You do have that capability. First of all, let's talk about what exactly a compound inequality is. A compound inequality is described as two inequalities joined by the word and or the word or. Okay, so we're going to be looking at both types of these. Let's start out with the quote-unquote and inequalities. Okay, these are the ones that kind of look like one big long inequality. Okay, there's not really a break. You've seen these before. They're all just kind of put together in one big one. So here's an example of what an and inequality looks like. We want to solve 10 less than or equal to 3y minus 2 less than or equal to 19. And then we're going to graph the solutions on a number line. Okay, now for purposes of solving, you can certainly break up the inequality. Okay, so what I'm going to do is I'm going to break it up with the left side and go 10 less than or equal to 3y minus 2, and then I'm going to break it up using the right side, 3y minus 2 less than or equal to 19. Now I'm going to solve these just as if they were equations. So I'm going to start by adding the opposite over here. So I get 12 less than or equal to 3y. And then when I divide by 3, I get 4 less than or equal to y. Okay, I did not divide by a negative, therefore I do not to flip that sign. But remember, that rule does apply. Now if we look at this one, I'm going to add 2 over. So 3y less than or equal to 21. And then when we divide by 3, we get y less than or equal to 7. Now what you'll notice is we can put both of these back together into one big inequality. So 4 less than or equal to y less than or equal to 7. And with an and inequality, you're definitely going to want to do that. The important thing to remember with an and inequality, or kind of a way to check yourself, is to make sure that these signs are both opening toward the right. Okay, you don't want them to get backwards. That is not correct. So make sure that you're writing your signs the correct way. Now if I put these on a number line, and with the number lines that we're going to use, we're not going to get too crazy with them. I would like you to label them with a variable. In this case it's y. But we just want to show that it's between 4 and 7. So I always like to put 0 on there as kind of a marker. Maybe 4 is here, maybe 7 is here. Remember, the less than or equal to means that there's a closed circle at both, and then you just shade that area in between. There it is. Okay, so that's what an and inequality is going to look like. Let's take a look at an or inequality. Okay, so the quote-unquote or inequality. These are the inequalities that are going to be literally separated by the word or. Okay, so here's an example of what these look like. We are going to solve x plus 3 less than 2 or negative x less than or equal to negative 4. And then again, we're going to graph the solutions on a number line. Okay, now these are already split up for us. So we can go right on ahead and solve them as if they were equations instead of inequalities. Okay, so for this first one, I'm going to add 3 to both sides. So that gives us x less than, oops, not less than or equal to, just less than negative 1. And then if I divide, now be careful because you're dividing by a negative 1, it's going to flip the sign, make it a positive 1. Okay, now with an or inequality, you can just leave it like that. That's your answer. Okay, so if it starts out separate, leave it separate. If it starts out together, then you want to put it together. Okay, so let's see, this is representing solutions of x, so I'm going to label my number line. I'm going to put 0 there as just kind of a marker, negative 1 here, maybe positive 1 is there. This tells me that I'm going to have an open circle at negative 1, and x is less than that. So I'm going to go this way. This sign here tells me that I'm going to have a closed circle at 1, and then I'm going to go that way. Okay? So that's it for both of them. Now, why are we going over this? Well, they actually, both of these actually have a lot to do with absolute value inequalities. Here's what I mean. Okay. Absolute value inequalities. Now again, I know I'm going through this quick. Feel free to pause and rewind as many times as you need. Okay, here's what it says. For all real numbers, A and B, where B is greater than 0, in other words, B is positive. Here's the first part. If the absolute value of A is less than B, then negative B is less than A is less than B. So in other words, it turns it into an and inequality. You see where B is, you put the positive on one side, the negative on the other side. If the absolute value of A is greater than B, then A is greater than B, or A is less than negative B. Okay? So if it's a greater than, it's going to turn it into an or statement. Now, a student last year came up with a great way of remembering this. If it's greater than, it turns it into an or statement. Okay, so you'll know that less than must be an and. If it's greater than, it turns it into an or statement. And again, this first one is the same as your original. The second one flips the sign and makes it a negative B. Okay, so let me show you how this works. I'll start out with a basic one, and then I'll show you some more complicated ones. All right, here we go. We want to solve absolute value of x less than 4. Okay, this is a less than, so that means I'm going to turn it into an and statement. So, negative 4 less than x less than positive 4. In this case, there's really not any more solving that we need to do. We can certainly graph it on the number line, though. Representing x, got a 0, maybe 4 is there, maybe negative 4 is there. Because it's a strictly less than and a strictly greater than, I'm going to use open circles, and then it's going to be this area right in there. Okay? Now if I use the same basic inequality, only I flip the sign, watch what happens. So absolute value of x is greater than 4. Greater than 4, so that means my first one is going to be the same, or I'm going to flip the sign and make it a negative for the second. That's it. So now if I graph these, making x 0, 4, negative 4, open circle, there we go. Okay? All right, let's try it with an actual equation in there. Okay? For this one, we want to solve the absolute value of 2x minus 2 greater than or equal to 4, and then of course we'll graph that on the number line, and then I'll do an or one, or a less than one over on the other side. Okay, so this is greater than, so that means we're going to bust it up like this. So that's the same. The second one, I'm going to flip the sign and make it negative. Okay, now I'm going to solve these just like I would equations. So I'm going to start by adding a 2. So 2x greater than or equal to 6. Then if I divide, looks like I get x greater than or equal to 3. For this one, add 2. So I get 2x less than or equal to negative 2. Divide by 2. There we go. So it stays an or. Now I just got to graph. 0, maybe negative 1 is there, maybe 3 is there. I'm representing x. So x is greater than or equal to 3, close circle, arrow. X is less than or equal to 1, close circle, arrow. That's it. So this whole thing is your answer. Okay, last one, and then I'm done. Then you have some time to work. Again, feel free to rewind this and show whatever parts you need to. For this one, we want to solve absolute value 750 minus r less than or equal to 250. Okay, this is a less than or equal to, so that means we're going to turn it into an and statement. So the first part we keep exactly the same. Now we just got to add this second part to it and do a negative 250. That's it. Okay. So now, just like we did the and one previously, we're going to split this up into 2 separate, and then we are going to solve from there. Okay, so if we look at this first one, I'm going to subtract 750. So if I subtract 750, I get negative 1,000 less than or equal to negative r. I have to divide by a negative here, so that means it's going to flip the sign. It becomes a positive 1,000, flip the sign, that becomes a positive r. Okay, now here, the second one, I'm going to again subtract 750, so I get negative r less than or equal to negative 500. Again, I am dividing by a negative, so greater than or equal to, I forgot to flip my sign, goodness. R greater than or equal to a positive 500. Okay, now I know this is an and statement. Watch what happens when I put it together. You should notice that those signs are opening to the wrong side. Okay, that is not correct. All right, we have to make sure that these signs are facing the other way. So what does that tell me? I have to reverse it. So it should go 500 less than or equal to r less than or equal to 1,000. And then of course when I graph this on the number line, maybe 0 is here, maybe 500 is here, I don't know, maybe 1,000 is there, I'm representing r. So these signs tell me close circles, fill in the area in between. That's it. This is your whole answer. Okay, we will do some more examples of these on Monday. Your assignment is over on the board. Have a fantastic weekend, and I will see you later. Bye.